So the Doppler effect is also something that we talked about in the wave unit. Again, the typical example for the Doppler effect is for sound waves. But again, especially for those of you in EC2, we talked about it again during the cosmology unit, right? The redshift and the blue shift. And so the Doppler effect is not exclusive to sound waves. All waves can undergo the Doppler effect, whether it's a water wave or a light wave or a sound wave. And so the Doppler effect is simply the change in wavelength and frequency that occurs when the wave source is moving. So I'm going to write that down. So the change in frequency and wavelength that occurs when the wave source is moving. And the idea is that the change in frequency and wavelength are inversely related. As one goes up, the other one will go down. And the reason for that is because of the wave equation. Or if you remember this, right? The idea is that the wave, that either the sound wave or whatever, isn't changing speed. It's not changing how fast it's going. And so what's happening is, instead, if, for example, if the frequency is increasing, then the wavelength is going to decrease, right? So, and of course, we're assuming that the wave source is moving, but the person observing it is, of course, stationary. If you're both moving, then this depends how quickly you're moving relative to each other. So if this is the person standing still, and the object here, I'm not going to make you guys deal with me drawing a car. Oh, apparently I am. Okay, there's a car. All right, if the car is moving towards them, then the idea is that the waves kind of get squished together. All right, and so that's going to cause the wavelength to decrease. And if the wavelength decreases, right, if this goes down, then because this doesn't change, the frequency is going to increase. So this is the source moving towards the observer. So this would be, in the cosmology unit, this would be what we talked about. This would be the blue shift, because the wavelength is decreasing. All right. If the source is moving away, then you're going to get the opposite, right? You have a person here, and the source is going this way, right? And so this is the siren. The idea is that here, the wavelength is going to increase. It gets stretched out as the object moves. So the wavelength increases and the frequency decreases. All right, so that's the Doppler effect.